In this video, we're going to talk about reflections. A reflection is an isometric transformation where you flip your source over a line of reflection, thus reversing the orientation. Here's an example of a reflection. We've got this cat, and we're going to reflect it over this line of reflection here. And you'll notice when we reflect it, it's just like a mirror, and if you connect any two corresponding points, the line of reflection is perpendicular to that and in the halfway point, or in the midpoint of the two. Here we have a simple reflection on an XY grid. Here's a dog, and we're going to reflect it over the Y-axis. So when I reflect it, it's just like going in a mirror, and the dog is going to be a mirror image. And notice that the ear of the dog is 2 units away from the Y-axis, and the image of the dog is also 2 units away from the Y-axis. You'll notice that all the other corresponding parts are also equidistant from the line of reflection. Here we have a rabbit, and I'm going to reflect it over the X-axis. And similarly, all corresponding parts are equidistant from the line of reflection. Now, we're not limited to reflecting over just the axes. We can reflect over any line. We're going to stick with horizontal and vertical lines only. For this reflection, we're going to reflect a bear over the line y equals 1. Notice we're not reflecting over an axis. And that line y equals 1 is a horizontal line, so our reflection is going to be a vertical reflection. You will notice that the x values of the reflection and the original image do not change at all because we are reflecting over a horizontal line. Please note, for example, the nose of the original bear is at 3 units away from the line y equals 1. And the reflection is also 3 units away from the line y equals 1. You'll notice that all the other corresponding parts are equidistant from the line of reflection. In this example, we're going to reflect over the line x equals 2, which is a vertical line. Let's reflect this point right here, located at 5, 3. We're going to reflect that. That's 3 units away from the line x equals 2, and so our image is going to be 3 units on the other side of x equals 2. So 5, 3 reflects to negative 1, 3. You'll notice that the y values did not change because we reflected over a vertical line. Now, what if we weren't given the graph and we were just given the point 5, 3 and x equals 2? How would we be able to solve this problem without graphing it at all? Well, we know that it's a vertical line, so the y values do not change. So we know our image will have the same y value. So that our image will have the value of 3. Now 5 is 3 units away from x equals 2, so we need to either add or subtract 3 from x equals 2 to find the x coordinate of the image. 2 plus 3 equals 5. That's our original point. So we use 2 minus 3 equals negative 1. So we know the x coordinate of the image is going to be negative 1, and we end up with negative 1, 3. Now let's look at the point negative 3, 7, and we're going to reflect that over the line y equals 5. Now, since y equals 5 is a horizontal line, we know that the x value is going to stay the same. So our image is going to have the x value of negative 3. So now 7 and 5 are 2 units apart. So we either need to do 5 plus 2 or 5 minus 2. Since 5 plus 2 is 7, we already have that. We do 5 minus 2, which is 3. And so that is our y value for our image. Things to remember are, remember that reflections over horizontal lines keep the same x coordinates, and reflections over vertical lines keep the same y coordinates. The x-axis is a horizontal line, and the y-axis is a vertical line. And then finally, always add or subtract from the line of reflection.